Hello, everyone. Thank you for being here. My name is Alex. I'm excited to present my design thinking project for a non-profit mobile application dedicated to supporting visually impaired individuals in Singapore. This presentation will walk you through the process I followed, from initial identifying the problem and empathizing with users, to designing, prototyping, testing, and finally planning for the real-world implementation. Over the next few slides, I'll highlight the key insights, solutions, and the lesson learned that shaped this app. Here's a quick rundown of what I'll cover today. I'll start by explaining the key navigation challenges for visually impaired individuals in Singapore and how this project addresses them. Then I'll walk through the design thinking stages, empathize, design, define, ideate, prototype, and test, before moving into specific plans for implementation. I'll close with a reflection on the process, what I've learned, and the next steps. This roadmap ensures we stay organized and that you know exactly what to expect. But before I begin, I would like to share some high-level statistics that explain my motivation for this project. In Singapore, there are over 40,000 blind or visually impaired individuals, a figure expected to rise as the population ages and life expectancy increases. Given that Singapore's population is around 6 million, this translates to roughly one person with visual impairment for every 150 people. Put differently, out of every 150 people you encounter in your daily routine, on your commute at work, or out or and about, at least one is likely to have a visual impairment. Now, consider how many people you come across in each day and how many of them you have noticed who are blind or visually impaired. Despite thinking I was quite observant, I had not personally come across someone visibly blind for years, until about 2 months ago when I encountered a visually impaired commuter on the MRT. What's more, when I was in my early 30s, I myself was once visually impaired in one eye due to cataract for almost a year. Without realizing how serious it was, I simply assumed my vision was getting worse and only sought medical help when it gradually worsened. That experience highlighted how easily vision problems can go unnoticed and underscored my commitment to raising awareness and supporting those living with visual impairment. I used the design thinking framework to explore a navigation solution. The process wasn't linear. As I refined design, new insights kept sending me back to earlier stages. In Empathize, I interviewed visually impaired users and advocacy groups, listening to issues like inconsistent audio cues and abrupt tactile paths. These real-life stories anchored my approach to create user-centric solution. Given our project timeline, we surveyed users to see if smartphone app would be more feasible than updating infrastructure. The results were clear: 90% use smartphones, 90% feel comfortable with apps, and 88% find real-time navigation tool essential. This guided us towards a non-profit mobile-based strategy rather than waiting for large-scale infrastructural changes. Next, we interviewed Daniel and Aisha, both visually impaired, to glean daily challenges from abrupt tactile paths to inconsistent cues. Their perspectives shape our user personas, highlighting how navigation obstacles affect both routine commutes and unfamiliar routes. We then map out their user journey to visualize exactly where they encounter problems such as needing real-time route adjustment or simpler voice prompts. Aisha's journey is a simpler one as she only requires to walk to the MRT station and again walk to the destination after alighting from the MRT. However, there's a lack of audio cue as she is on foot. Daniel's journey is a more complex as there is more transits from foot to bus than to MRT. Not to mention, Daniel's profession as a freelance singer requires him to travel to different work locations, adding on to the challenges. By creating this persona and user journey, we grounded our design decision in real user experiences rather than just assumptions. This process highlighted precisely where non-profit app-based navigation solution can make the biggest difference in promoting independence and ease of travel for visually impaired users like Daniel and Aisha. From these insights, we formalized the problem. Visually impaired users lack reliable real-time navigation tools, facing incomplete tactile paths and inconsistent audio guidance, leading to anxiety and reduced independence. To derive at the problem statement, we use the 5 whys: to uncover root causes: inconsistent infrastructure, limited integration of assistive technology, and low public awareness. Advocacy efforts alone have not shifted perceptions enough. Therefore, we saw an app as a tangible tool to raise acceptance and fill immediate needs. Hence our statement. In Singapore, visually impaired individuals frequently encounter abrupt tactile paths, inconsistent audio guidance, and limited real-time navigation, hampering daily independence and sometimes causing social exclusion. In ITOD, we explored wide-ranging solutions like real-time guidance, community support, and route learning, using sample and scope mapping to address the core pain points. Moving on to the ideate stage of our design thinking process, I formed a focus group, and we explored a range of possible solutions using brainstorming techniques like scope mapping and Scamper. Our central focus was to create a practical smartphone app. As the survey results confirm, it's both feasible within our project's timeline and preferable to a lengthy infrastructure changes. In particular, we zeroed in on real-time audio prompts for directions, simplified user flow design around the day-to-day challenges faced by people like Daniel and Aisha. We also wanted to keep it user-centric by minimizing screen complexity, prioritizing straightforward voice commands, and ensuring the app could adapt to different levels of tech comfort. In order to achieve this, we first summarized the key pain points we heard repeatedly, like inconsistent audio cue, missing real-time information, and the need for simpler, more intuitive user flow. From there, we converted each pain point into clear design goal. For instance, resolving missing real-time information led us to integrate a reliable audio prompt system addressing inconsistent cues, meant ensuring voice alerts were both timely and user-friendly. By distilling these challenges into actionable objectives, we could focus our brainstorming and ultimately our solution on exactly what Daniel and Aisha told us they needed most. Ultimately, this ideate phase helped us to translate user feedback into tangible features, laying the groundwork for our prototypes. In designing our app, we developed a scope map to outline how features will evolve 3 major iterations, ensuring we meet core needs early while leaving room for enhancement. The first iteration focused on basics, delivering simple audio prompts for navigation and a minimal community assistant function. This approach kept our initial release achievable within timeline, providing immediate value to visually impaired users who needed help navigating familiar routes. The second iteration expanded on that foundation by enhancing the community assistant feature, adding a volunteer directory and scheduling options, and introducing personalized route setting. We integrated feedbacks from early testers who wanted more flexibility in how they receive help and route suggestions. Finally, our final scope included real-time navigation integration, leveraging more robust APIs for accurate mapping data and completing the feature set with crowdsourced data uploads and a more detailed audio guidance. This ensures the app not only handles daily commutes, but also empowers the user community to keep navigation info current, addressing real-world conditions in near real time. By mapping our scope across these 3 iterations, we ensured each build was manageable, user-focused, and iterative, allowing us to deliver value quickly and refine based on real feedback before rolling out the complete solution. Using Scamper substitute, combine, adapt, modify, put in another use, eliminate, reverse, we dissected typical map apps, combining real-time data with audio guidance, adapting standard UIs for visually impaired needs, and eliminating redundant menus, shape an accessible, timeline-friendly solution. From our brainstorm came forth main features for the app. The first one is the real-time navigation. Users can receive up to the minute guidance and route adjustment without waiting for external updates. Next, we have the community assistance. which connects visually impaired users to volunteer or carers willing to offer immediate help, like talking them through tricky intersections. The third feature is a personalized route learning. This uses AI to adapt each user's preferred path over time, suggesting shortcuts or quieter routes they might find more comfortable. Lastly, we are incorporating a crowdsourced data element where users can report issues like broken tactile path and misleading audio signals. This not only keep the system fresh, but also foster a sense of community ownership. Now, together, these four features aligns perfectly with our value proposition, providing a user-focused, real-time, and evolving solutions that can be implemented more quickly than major infrastructure overhauls. Our app is a non-profit, user-friendly, and aims to provide immediate high-impact navigation solutions. Beyond real-time cues, it promotes social awareness about visually impaired individual needs, leveraging smartphone, familiar, cost-effective, over slow infrastructure updates. Next, in prototype, we converted ideas into tangible wireframes and user flows, testing everything from audio clarity to menu layouts in safe-to-fail environment. We began with conceptual prototypes showing potential user journeys and pinpointing where navigation prompts or volunteer help should appear. This ensured each step addressed Daniel and Aisha's real-world challenges. Early wireframe illustrated essential features, real-time navigation, and on-demand assistance. These rough sketches let us easily tweak button placement, audio timing, and user flow. Only once we validated this structure did we proceed to more polished designs. We gave prototypes copies to Daniel and Aisha for 2 weeks. Aisha suggested adding a feedback mechanism. Daniel requested shorter volunteer wait times and an ability to schedule help in advance. He also wanted more control over personalized routes, letting him save or delete them manually. This user-led feedback shaped our next round of improvement. Lastly, our volunteer didn't have specific feedback beyond noting that the crowdsourced feature works well for uploading her reports. This is a sign that at least some aspects of this prototype are already hitting the mark. Overall, this comment reinforced the need for transparent user control, flexible scheduling, and an in-app feedback mechanism to refine our navigation solutions further. Finally, the test phase validated our design choices. By installing prototypes on our user phone, we caught issues we had not anticipated, ensuring the final product matched real needs rather than assumption. We then refined the conceptual prototype addressing Daniel's wait time concern with 3 minutes cap and a cancel button, adding Aisha's recommended in-app feedback tool and giving users more control over route learning. This paved the way for high-fidelity design. We streamlined the start screen and the main menu with large icon, a home option for every screen, and a dedicated feedback button. This ensures partial vision users and those relying on audio cues can navigate easily from the moment they open the app. Here we are showcasing the real-time navigation interface in its high-fidelity design. While Daniel didn't offer specific feedback on this feature, we recognize the need for a seamless way to real-time direction together with personalized route learning. As a result, we added a clear Save Route button so users can quickly tap into any preferences they have set, even while relying on the live route data. This ensures that if someone, for instance, have a preferred path to an MRT station, they can load that route instantly without manually re-entering it. We have also kept the interface minimal and intuitive, large icon, straightforward voice prompt, and a single location entry for destination. Ultimately, our goal was to combine up-to-date navigation, showing road closures or route changes in real time with easy access to users' personally curated journeys. This integration helps visually impaired users smoothly switch between their known paths and any new routes they may need on the fly. Here's a refined community assistance feature where we address Daniel's feedback about the long wait time by capping the response window at 3 minutes and adding a cancel button with cancel request option. This prevents users from having to close and reopen the app if no volunteer responds promptly. We also introduced an advanced scheduling function, crucial for those like Daniel who plan their day around multiple gigs and do not want any last-minute uncertainty. Now they can book volunteer support for a specific date and time, and of course, we have kept the interface simple, large button, clear instructions, and built-in audio guides for each step. By making these changes, we have streamlined how visually impaired users can seek help, whether they need on-demand assistance or prefer to plan ahead. Now let's explore the personalized route learning feature. This component works quietly alongside our real-time navigation, observing which paths a user frequently takes. Over time, the app can suggest shortcuts or quieter routes aligned with users' habits. But more importantly, it's a passive and user-driven feature. People can still choose or delete suggested routes as they prefer. If a user is comfortable with a certain path, they can lock it in. If not, they can disregard the app suggestion or manually teach it an alternative route. That ensures our tools respect individual preferences and does not lock anyone into a path that doesn't feel right for them. It's about gently adapting to each user's comfort level rather than forcing new routines. Finally, our crowdsource feature invites the entire user community, visually impaired individuals, volunteers, even friends or family, to contribute updates about tactile path, changes in audio signals, or other accessibility details. If a tactile path is newly repaired or an elevator is temporarily out of service, user can post this information in real time. A simple verification process keeps the system accurate, and once approved, everyone else benefits from the update. By pulling insights from multiple users, we ensure navigation data stay fresh and reliable. It's a collective effort that not only supports daily travel, but also fosters a greater sense of community ownership in making public spaces more accessible for everyone. For our implementation plan, we use Scrum approach with short, focused sprints. The goal is to push out an initial working app by 4th of January, so visually impaired users can benefit from core features like real-time notification and community assistant as soon as possible. So here's an overview of the sprints in our timeline. During sprint 1 and 2, we finalize user flow, build out the MVP, and conduct quick internal tests. We plan to start beta testing in sprint 3 or 4, giving Daniel and Aisha early access so we can incorporate their feedback right away. By late December, we aim to have a near finished product ready for final polishing, leading to a release candidate. The official launch is set for 4th of January, ensuring our non-profit app meets its deadline and essential features in place. After that release, we'll integrate Google Map API, which further improve our real-time navigation accuracy while cutting resource costs overall because our app is non-profit. We rely on widely available updated map services instead of developing our own infrastructure. This rolling update strategy allows us to keep refining routes personalization, volunteer management tools, and user experience, ensuring that the app remains relevant and user-centric well beyond the initial date. In retrospect, design thinking was far from linear. Refining high-fidelity design often sent us back to earlier stage, while juggling evolving requirement was challenging. Each loop revealed new opportunities like simplifying volunteer flows or adding a feedback mechanism. This iterative user-driven process ultimately strengthened our solutions, showing the true power of non-linear, people-focused design. Now, I thank you for the time to listen to my presentation. I welcome any questions you might have about our process, the final app, or how we plan to continue refining this non-profit initiative for visually impaired travelers. Thank you.